the quadratic formula actually will give you the x-intercepts. Now, if you think about it, the x of your vertex is the average, is always going to be in the middle of your x-intercepts. And so you can take that negative b plus the square root of b squared minus 4ac all over 2a, the negative b minus 1, and average those together. Add them together and divide by 2. And so what you're going to find is that the x of vertex is negative b over 2a. Now, my regular class was struggling with that negative, you know, so I'm going to write it like I did with them, if you struggle a little bit with double negatives and all that kind of stuff. And then to find the y, you're going to have to, in the old days, when we didn't have graphing calculators, we would just plug that number in to our equation. Once we got x, we would put it there and do the arithmetic. To me, that sometimes is faster, but since you're going to graph it anyway, I'll show you what we'll do with that one. And we're still going to do all the other stuff, so I think we're going to be good. Your x-intercepts are not going to be crazy ones, so I will write that x-intercepts can be found by the quadratic formula. I'll just put, let's do it like this. Because since this is in quadratic form, it wasn't easy with the 33 because I can't easily put this into the quadratic formula. But this I can. If I have time, we can do it, but I'm not going to push that too much. So really, we're not doing anything different other than how we find the vertex. But the nice thing is, tell me what the format for a y-intercept is. Like, the y-intercept always has what? On every point on the y-axis has what in common? It has 0 for the x. Now, here's the cool part. If you put 0 in for x, look, that becomes 0, and that becomes 0. And so on this format, which is really nice, the C is your y-intercept. Right there. On the ACT, you don't want to have to depend on graphing it every time because it's just a time thing. So let's do f of x is equal to negative x squared minus 4x. Okay, and I'm going to write it. A is negative 1, B is negative 4, and C is 0. Now remember, that's one you have to be careful with because B is your coefficient of your x and C is your constant. So if it's just minus 4 as opposed to minus 4x, you have to which one's B and which one's C. Now, if I'm going to graph it on graph paper, I have to know my vertex first. So let's do this. And let's do x equals negative b over 2a. Now, this is the way I did it for them. I put this negative out front, and then we put the b over 2a in parentheses. So I'm just going to do it that way for y'all because you got a lot of negatives. So b is negative 4, and 2 times negative 1, well, I'll go ahead and do it like that for the first one. So I'm just plugging in. And so I've got negative on the outside. Now, what's all this going to become? Negative 4 over negative 2. Yeah, you're right. But I want to know what that number is going to be. And negative 4 over negative 2 is positive 2. But negative times positive 2 is negative 2. So my x of my vertex is negative 2. Okay, do I know my axis of symmetry? If you know the x of the vertex, do you know the axis of symmetry? Yes, x equals negative 2. Do we know I don't know the order that we do these in. What do we usually do next? The y-intercept? Okay. Yeah, I think we do y-intercept before we do. It doesn't really matter, but I usually go ahead and do those. The y-intercept is going to be, remember, the x is 0, and then your y is whatever c is. So it's 0. The origin is where it's going to cross the y-axis. And then the x-intercepts, we'll just leave that for just a minute. You would have to do the quadratic formula of this, put that in, which we could do. Let's just use the graph. It's going to be pretty easy, I think, anyway. And then we have domain, which is all reals. And then the range, okay, we'll have to know our y of our vertex to be able to do that. And you know I haven't left much room for this, but you can squeeze it in because I had room for 2 more, but we're just going to do 1 more. If you've got room for it, it's going to be down like this. So if you can get something like that, you'll have plenty of room for it. Now, they're a lot quicker to type in your calculator. Because you don't have to mess with parentheses. And I wasn't in Zoom 6 yesterday, so I'm going to go ahead and do that for some reason. Like I said, old school, you had to take -2 and put it there, and put it there, and do the arithmetic to get the y. Time-wise, that still might be quicker, especially on an easy one like this. Now, if that's a fraction, it's a lot more involved. How can I find it on my calculator? No, the vertex, the y of the vertex, because I want to graph it. I want to graph my vertex on my paper.
Okay, this one done. How did you write that in there?
You just go to y equals and type that.
Oh, done.
Yeah,
Okay.
you knew that. That's okay. Somebody else was interested too. They just didn't ask it. How would you find it? What helps you when you put a point in that you can find the y?
Do
Trace.
and then the -2.
Yeah, and see, there's your y-intercept. But I'm telling y'all, I have graphed some that it's not starting on the y-intercept. So be careful. Always make sure if it starts somewhere else, because I was thinking it always does that. But I've been graphing a few the last few days that it might start at -2. So just always put 0 in if it has to. So if I put -2 in, what is the y? 4. So there's my vertex. So I'm going to go plot that. 1, 2, 3, 4. And then my stretch is -1. So I'm going to go down 1 over 1. Now here's where, if I can graph them, somebody asked me, I think Grace asked me, and I've had other people ask me, if the y-intercept is reasonable, and it is, I'm going to plot that one. If the x-intercepts are reasonable, I'm going to plot that. And I think you can count that. What is the other? And also it's symmetrical. You know, if this is my axis of symmetry, if this one's on there, this one is. But I think you can count it, can't you? Isn't that -4? You can hit it on your trace. It is. So plot them, and they just make your graph easier. It makes it look more perfect if you say it like that. So the main thing is, from this, what are you taking home? The idea of -b over 2a, that you can't graph it until you put it on the calculator or figure out what the x and the y are of the vertex.
So you can either graph it or put your x in and figure it all out.
Yes, if I had put -2 in here, see, that would have been +4 times -1 would have been -4, and then it would have been +8, and so -4 plus 8 is +4.
Okay.
Yeah. Number 2. I don't think I numbered that. Number 2. And I try to stay away from, even when we graph these as cubics and 4th degree and 5th degree, I try to stay away from irrational and imaginary zeros and stuff. Remember, x-intercept's another name. Yes, ma'am. What was the range? We didn't put it, did we? Tell me about the y's. Y's are less than or equal to 4. +4. See, 4 up here.